In this lecture, we will answer 3 questions. The first question states to describe the formation of precipitation and explain the differences in rain, snow, sleet, and hail. So first off, the coalescence process is precipitation from warm clouds, and it is defined as a theory of raindrop formation in warm clouds which are above 0 degrees Celsius, in which large cloud droplets collide and join together with smaller droplets to form a raindrop. Opposite electrical charges may bind the cloud droplets together as well. Next is the Bergeron process, which is precipitation from cold clouds, and is defined as the process is a theory that relates the formation of precipitation to supercooled clouds, freezing nuclei, and the different saturation levels of ice and liquid water. And this precipitation formed from this process will occur in middle latitudes. Next is rain. Rain is known as liquid drops of water that fall from a cloud and have a diameter of at least 0.5 millimeters. Most rain originates in either nimbostratus clouds or in towering cumulonimbus clouds that are capable of producing unusually heavy rainfalls. Next is snow. Snow is a solid form of precipitation produced by sublimation of water vapor. Produced in the supercooled clouds where water vapor is deposited as ice crystals that remain frozen during their descent. The shape, size, and concentration of snowflakes depends to a great extent on the temperature at which they form. Next is sleet, which is frozen or semi-frozen rain formed when raindrops freeze as they pass through a layer of cold air. It is a wintertime phenomenon and refers to the fall of small particles of ice that are clear to translucent. For sleet to be produced, a layer of air with temperatures above freezing must overlie a sub-freezing layer near the ground. When raindrops, which are often melted snow, leave the warmer air and encounter the colder air below, they freeze and reach the ground as small pellets of ice the size of raindrops from which they formed before. Lastly is hail. And hail is the precipitation in the form of hard, rounded pellets or irregular clumps of ice, and are only produced in large cumulonimbus clouds, they begin as small ice pellets that grow when supercooled water droplets are added as the pellet moves through the cloud. The strong updrafts can carry the hailstones through many cycles and increasing the size of hail by adding new layers of ice with each cycle. The hailstone will continue the process until there is a strong downdraft to pull the pellet out of the cloud, or it becomes too heavy to be supported and will fall out. The next question states to sketch and label the 4 types of fronts including the general weather of each. So first is a warm front, which is a front which a warm air mass overrides a retreating mass of cooler air. As warm air ascends the retreating wedge of cold air, it expands and cools adiabatically to produce clouds and frequently precipitation. The first sign of the approach of a warm front is the appearance of cirrus clouds overhead. Because of their slow rate of advance and very low slope, warm fronts usually produce light to moderate precipitation over a large area for an extended period. They are also occasionally associated with cumulonimbus clouds and thunderstorms. On a weather map, you will see that a warm front is denoted by a red line with half red semicircles on the line. Next is a cold front. A cold front is a front along which a cold air mass thrusts beneath a warmer air mass. A cold front will bring more extreme weather than a warm front will because of the increase in the front's rate of motion and the steepness of the slope. The heavy downpours and vigorous wind gusts associated with mature cumulonimbus clouds frequently result. A cold front produces roughly the same amount of lifting as a warm front, but over a shorter distance. As a result, the intensity of precipitation is greater, but the duration is shorter. In addition, a marked temperature drop and wind shift from the south to west accompany the passage of the front. The sometimes violent weather and sharp temperature contrast along the cold front are symbolized on a weather map by a blue line with a blue triangle-shaped points that extend into the warmer air mass with which you see depicted in this image. Next is a stationary front. In this situation, the surface position of a front does not move. The flow on either side of such a boundary is nearly parallel to the position of the front. On a weather map, stationary fronts are shown with the blue triangular points on one side of the front and red semicircles on the other. At times, some overrunning occurs along the stationary front, most likely causing gentle to moderate precipitation. Lastly is an occluded front, and this is a front formed when a cold front overtakes a warm front. It marks the beginning of the end of a mid-latitude cyclone. As the advancing cold air wedges the warm front upward, a new front emerges between the advancing cold air and the air over which the warm front is gliding. The weather of an occluded front is generally complex. Most precipitation is associated with the warm air being forced aloft. When conditions are suitable, however, the newly formed front is capable of initiating its own type of precipitation. Lastly is why is lifting of air important? And then discuss two processes of lifting. So the lifting of air is important because as it rises, it will expand and cool adiabatically. And if the air is lifted sufficiently enough, it will eventually cool to its dew point temperature where saturation will occur and clouds will begin to develop. One form of this lifting is convergence, which is a horizontal pileup of airflow resulted in upward movement. When air flows in from more than one direction, it must go somewhere. Because it cannot go down, it goes up. This leads to abiotic cooling and possible cloud formation. Convergence can also occur when an obstacle slows or restricts horizontal airflow. Next is orographic lifting. As air descends a mountain slope, adiabatic cooling often generates clouds and large amounts of precipitation. In fact, many of the rainiest places in the world are located on windward mountain slopes. By the time the air reaches the leeward side of the mountain, much of its moisture has been lost. If the air descends, it warms adiabatically, making condensation and precipitation even less likely. The Great Basin Desert of the western United States lies on a few hundred kilometers from the Pacific Ocean, but it is effectively cut off from the ocean's moisture by the imposing Sierra Nevada. Because of this effect, one side of a mountain will almost always be very green and luscious, while the other side is more dry and barren. Thank you.